Here's the video answer key for the IM3 final exam for high school math enrichment. Let's start with the first problem. Use the dot plot to find the following. Round answers to the nearest hundredth. So first we need to find the mean. To find the mean, you take the sum of all the values and divide it by the total number of values that exist. So we have 4 6's, so 4 times 6. And we also have 2 7's, so 2 times 7. And we also have 4 8's, and we have 1 9. And we divide it by the total number of values that exist. So there's 4 6's, 2 7's, that's 6 numbers, plus another 4 8's, that's 10 numbers, plus a 9 is 11 values. So now we just multiply and add accordingly. 4 times 6 is 24, 2 times 7 is 14, 4 times 8 is 32, plus 9, all over 11. 24 and 14 make 38. 38 plus 32 make 70. 70 plus 9 is 79. So 79 over 11. And if we use a calculator to calculate that, we end up with 7.18 as our mean. To find the median, you take all the values, line them up in order from least to greatest, and then find the middle value. So using this dot plot, these numbers are already lined up from least to greatest. So I'll cross out 1 6 and 1 9. Another 6 and an 8, another 6 and an 8, another 6 and an 8. Then we cross out 1 7 and 1 8, and we have our median of 7. Lastly, the mode represents the number that appears the most, and in this case 6 appears 4 times and 8 appears 4 times. So our mode is 6 and 8. On to the next one. Which of the following graph groups has a higher standard deviation? Explain your reasoning. So standard deviation means how spread out the data points are. And if it has higher standard deviation, that means the data points are spread out more. You can see that the range between these numbers is around 5, whereas the range between these numbers is 9. So group B has a higher standard deviation because the data points are more spread out. Compared to group A. Question 6. A box of chocolates contains 4 milk chocolates and 8 dark chocolates. You randomly pick a chocolate and eat it. Then you randomly pick another piece. What is the probability that the first piece is milk chocolate and the second piece is dark chocolate? So the first piece is milk chocolate and the second piece is dark chocolate. Okay, so you will notice the key word here is and, which means the multiplication rule for probability. So the probability of milk chocolate times the probability of dark chocolate. For milk, there are a total of 4 pieces that are milk chocolate out of 12 total, because 4 plus 8 equals 12. And we multiply it by dark chocolate, so that's 8, and since we already pulled out 1, we only have 11 left over. And remember, we're multiplying because we are taking the multiplication rule involving, and you can notice that by the word and. When you see or, that means addition rule. So now we can just multiply the two values, and we get 4 times 8 is 32, and 12 times 11 is 121. 132. 12 times 11 is 132. And if we simplify that, we'll get 8 over 33. Divide the numerator by 4 and denominator by 4. And 8 over 33 could be your answer, or you can also say 24%. Either one works. Problem 7. Given f of x equals negative 6x plus 1 and g of x equals 2x squared minus 3, find g of negative 3. So this is g right here, our function gx. So every time I see an x, I need to replace it with negative 3. So equals to 2 times negative 3, which is our x, squared minus 3. So using PEMDAS order of operations, we're going to do parentheses first, negative 3, and then exponents, square, negative 3 times negative 3 is positive 9. And after we do parentheses and exponents, we do multiplication. So 2 times 9 is 18. And lastly, we do subtraction. 18 minus 3 is 15. So our answer in this problem is g of negative 3 is equal to 15. For our next problem, find x if f of x equals to negative 11. So we need to use that first function, f of x equals negative 6x plus 1. So we know that f of x is equal to negative 11, and we set that equal to our function, negative 6x plus 1. Solve for x by subtracting 1 on both sides. And then we're left with negative 12 equals negative 6x. Divide both sides by negative 6, and we get x is equal to 2. Question 9. Juan surveyed the students in his grade. He found that 78 students owned a cell phone, and of those, 57 owned wireless headphones. There are 13 students that do not own a cell phone, but do own wireless headphones. 9 students do not own either device. So when you read this word problem that involves conditional probability, you'll notice that it's talking about very specific things. It talks about people owning a cell phone, people owning wireless headphones, people not owning cell phones, and people owning neither. So the words that keep reappearing, the ideas, include cell phones and headphones. So we're going to have one column called cell phones, another one we're going to call no cell phones, and then we're going to have one called headphones and no headphones. Okay, so he found that 78 students owned a cell phone. So cell phones, how many own cell phones? A total of 78 students owned cell phones. And of those, 57 owned wireless headphones. So 57 of those people that owned a cell phone, 78 total, 57 of them owned headphones. Then there are 13 students who do not own a cell phone. So no cell phone, 13. But do own wireless headphones. So 13 of them do not own a cell phone, but they do own wireless headphones. And then 9 students do not own either device. So that means no headphones and no cell phones. Total of 9. So we want to find the total of number of students who own no cell phones. We take 13 and 9, and that equals to 22. If we want to find the total number of students who own no headphones but do own cell phones, that would be 57 plus a number equals 78, so 21. And then to find the total for the number of students that own headphones, we have 57 plus 13, which is 70. And then the number of students who own no headphones, 21 plus 9 is 30. Now we check our totals to see if all the calculations make sense. 70 plus 30 makes 100, and 78 plus 22 makes 100. So we have our two-way frequency table completed correctly. The first question A asks, what is the probability that a random student selected does not have wireless headphones? Okay, so we know there's a total of 100 students. And of those 100 students, how many do not have wireless headphones? Headphones, so no headphones, that's a total of 30. So 30 out of 100 is the same thing as 3 over 10, or 30%. For our second problem, we're looking at what is the probability that a random student with headphones who was selected also has a cell phone. So we need to look at how many students have a headphone. That's a total of 70 students have headphones. They also have a cell phone. So of those 70 students, how many have a cell phone? 57 of them have headphones and cell phones. So 57 out of 70 could be your answer, or 81%. If you use the calculator, calculate that. Question 10. Describe the correlation of the following scatter plot below. Be sure to include information about the direction, form, strength, and any unusual features. So direction, so it looks something like that. Most of the points along the scatter plot, and the direction is facing down. This is a parabola facing downward, okay? So we have negative as our direction. The form in this case is a quadratic. It's a negative quadratic. And then the strength, it looks pretty moderate. It's not strong. If it was strong, the points would be a lot closer. And if it was weak, then the points would be more scattered about. And then any unusual features, I think there is an outlier right there. Okay. So that's number 10. Number 11, write the equation in slope-intercept form of the line that contains the 2 points, 4, -2, and 0, -1. So whenever we want to find an equation, we want to find the slope first. So slope can be seen as change in y over the change in x, or y2 minus y1 over x2 minus x1. In this case, our y2 is going to be -1, and we're subtracting y1, which is -2, and then dividing that by x2, which is 0, minus x1, which is 4. So -1 minus -2, that's -1 plus 2 over -4, or in this case, -1 plus 2 is 1, and over -4. So we know our slope is -1 over 4. Now to find the y-intercept, we already have it right here, 0, -1. So our final solution needs to be written in the form of y equals mx plus b. In this case, y equals -1/4 x minus 1, which is our y-intercept. If they did not give us this y-intercept of 0, -1, you can plug in any of the 2 points to solve for b. Question 12. Write the equation in slope-intercept form for the line that contains the point 4, -4, and is parallel to the line y equals -1/2 x plus 5. Recall that 2 lines are parallel when they have the same slope but different y-intercepts. So we know that the equation of lines y equals mx plus b, and for this to be to find our answer, we know that it needs to have the same slope, but it should have a different y-intercept to be parallel. So to solve for b, we're going to plug in the x and y value, and they gave us the x and y value right here, 4, -4. So let's plug that into the equation. Our y is going to be -4, and our x is going to be +4, and we just solve for b. -1/2 times 4 is going to give us -4 over 2 plus b, and then -4 over 2 is just -2. Then we add 2 on both sides, and we get b is equal to -4 plus 2, which is -2. So our line that is parallel is going to be y equals -1/2 x minus 2. Same slope, different y-intercept. +5 in the original equation, and -2 for our second equation. Question 13. Graph the piecewise function. So let's look at it one piece at a time. We'll start with the first one. when x is less than or equal to 0, so where's x less than or equal to 0? Right here, and then the y value has to equal to 2. So y is 2 over here, but anytime the x value is less than or equal to 0. So all these numbers on the left hand side are less than or equal to 0, and we're going to make a solid point because this is less than or equal to. Okay, so this is at 0, this is at -1, -2, -3 for all the x values. So we have our first line. Our second equation reads as f of x equals -2x when x is between 0 and 1. So between 0 and 1, we have a slope of -2x with the y-intercept of nothing. So it cannot be at 0 because it's an open circle. So I'll leave an open circle at 0. And then I need to go down to 1 over to the right. So down to 1 over to the right looks something like this. And it only goes up to when x equals to 1. So we'll make it a closed circle because it's less than or equal to. And then for our last equation, we have 2x minus 4 when x is greater than 1. When 1 is less than x or x is greater than 1. So anytime we see where we're looking at when x is 2, 3, 4, 5, 6, 7, 8, so forth, all the way to infinity. So let's write the equation first, 2x minus 4. So we go -4 on the y-intercept, 1, 2, 3, 4, -4. So that looks like something like this right here. And then I go up to 1 over, up to 1 over, and so forth, and repeat that. But I only want to include the values where x is greater than 1. So it should look something like that. And we don't need this point because it's not included. So that's how you graph the piecewise function. 14. Write the equation that matches the graph below. Put your answer in f of x equals form. Okay, so we have to identify what type of function this is first, what type of graph this is. And in this graph, we can see it's a quadratic. Whenever we have quadratics, it's always in the form of a times the quantity of x minus h squared plus k. Okay, and we can see that the graph, usually for quadratic, it's facing upward, and the vertex is at 0, 0. But in this case, the vertex is at -3, comma 1. So to fit it in this function right here, we know that our vertex is at -3, comma 1. So if we take, it says x minus h, so x minus -3, that gives us x plus 3 squared, and then our k value is going to be 1 plus 1. So our solution is f of x equals negative x plus 3 squared plus 1. And it's negative because we want the graph to reflect along the x-axis. For question 15, graph the following equation. Negative absolute value of x plus 5 minus 2. Okay, so when we have this function right here, we have an absolute function, absolute value function, and for absolute values, they generally look something like this. Once again, where the vertex is at 0, 0. So we know that originally we need to move the vertex over 5 units to the left and then 2 units down. This is what we call our vertex. So originally it looks something like, let me draw the original graph. Let's use dotted lines in this case to show the original function. But I want to do the transformation function, so I'm going to move 5 units to the left, 1, 2, 3, 4, 5, and then 2 units down, 1, 2. So this is where the vertex is actually Move 5 to the left, 2 down. And then I need to reflect it along the x-axis because it has a negative in front. So it needs to be facing down. And that's what the graph looks like. The one in blue. Question 16. Solve for x. 4a equals x plus 1 over 3x minus 6. So whenever you have problems like this, where you're trying to rearrange literal equations, get rid of your denominator. So multiply 3x minus 6 on both sides. And 3x minus 6 divided by 3x minus 6 makes 1. And now we have on the left side 4a times 3x minus 6. And on the right side we have x plus 1. So we have such a problem. We want to distribute 4a times 3x gives us 12ax. 4a times negative 6 gives us negative 24a equals x plus 1. We want to make sure that all the x's are on one side of the equation and all the non-x's are on the other side of the equation. So I see 12ax first. I'm going to have all the x's on the left-hand side in this case. So subtract x on both sides. That leaves us with 12ax minus x minus 24a equals 2, 1. Now I'm going to add 24a on both sides because I don't want it on the side of the x's. So now we have 12ax minus x equals to 24a plus 1. We need to pull out an x, factor out an x from the 12ax minus x side. So factoring out an x, we're left with 12a minus 1 equals to 24a plus 1. And then we divide both sides by 12a minus 1 to isolate for x, and our final answer is going to be x equals to 24a plus 1 divided by 12a minus 1. Question 17. 6 times the absolute value of negative x plus 3 plus 4 is greater than 10. So whenever we have such a problem, we want to make sure that we follow the order of operations. And to solve a problem, you want to do everything in inverse. So we're going to take care of the adding and subtracting first. So I'm going to subtract 4 on both sides. And we're left with 6 times the absolute value of negative x plus 3 is greater than 6. After we do the opposite of adding, which is subtracting, we're going to do the opposite of multiplying, which is dividing. So we divide 6 on both sides. And we get the absolute value of negative x plus 3 is greater than 1. So now we're going to create two equations. One that says negative x plus 3 is greater than 1. And then the other one is going to say negative x plus 3 is greater than 1. So when we have negative x plus 3 is greater than 1, we can just subtract 3 on both sides. And we get negative x is greater than negative 2. Divide by negative 1 on both sides. And then remember, whenever we divide or multiply by negative, we need to flip the inequality symbol to make the statement true. So x is less than 2. That's one of our solutions. And then for the other solution, we distribute the negative sign in front of the negative x plus 3, which gives us positive x minus 3 is greater than 1. Then we add 3 to both sides, and we get x is greater than 4. So just to check if our answers are correct, so I'm going to plug in x values. Let's say I plug in x equals to 0 in this case, because 0 is less than 2. Plug into the original equation, negative 0 plus 3, it's going to give me positive 3. 6 times 3 is 18. 18 plus 4 is 22. 22 is bigger than 10. So that does work out. And then let's say I need to pick a value where x is greater than 4. So let's say x equals to 5. So plug in 5, negative 5 plus 3 inside the absolute value. That gives us negative 2. The absolute value of negative 2 is equal to positive 2. 2 times 6 is 12. 12 plus 4 is 16. So 16 is greater than 10. So both our answers are true after checking it. So question 18. Write the equation for the graph below. So whenever we have a line, we want to make sure that we find where the y-intercept is first and write it in the form of y equals mx plus b. So y-intercept in this case is negative 2. Our slope, we go up 1 and 3 to the right. So y equals 1 over 3x minus 2. And now you notice that it was shaded above the line. So above means greater than. So y is greater than or equal to 1 over 3x minus 2. And we want to make sure it's equal to because this line is solid, not dotted. Question 19. Alyssa's church is selling tickets to a choral performance. On the first day of ticket sales, the church sold 3 child tickets and 3 adult tickets for a total of $30. The church took in $52 on the second day by selling 4 child tickets and 6 adult tickets. What is the price each of 1 child ticket and 1 adult ticket? Okay, so let's call X child ticket and Y the adult ticket. So on the first day of ticket sales, sold 3 child tickets and 3 adult tickets for a total of $30. The church took in $52 on the second day by selling 4 child tickets and 6 adult tickets for $52. So now we just need to solve for one variable, and then after eliminating one variable, we'll plug it in to solve for the other variable. So let's multiply the first equation by negative 2 to cancel out the x's. That's going to give us a new equation of negative 6x minus 6y equals to negative 60. And our bottom equation is going to still be the same. 4x plus 6y equals to 52. So now we simplify. The negative 6y and the positive 6y cancel each other out. The negative 6x plus 4x gives us negative 2x. And negative 60 plus 52 is equal to negative 8. So divide negative 2 on both sides. And then we get x. Our child ticket is worth $4. If a child ticket is worth $4, we're going to do 4 times 4 plus 6y equals to 52. 4 times 4, using the second equation, is 16. Plus 6y equals to 52. Subtract 16 on both sides, and we're left with 6y is equal to 36, or each adult ticket is going to be worth $6. And each child ticket is going to be worth $4. Question 20. Solve the following systems of equations. Negative 2x plus y plus 2z equals 2. 4x minus 3y plus 3z equals negative 20. And 2x plus y minus z equals 0. Okay, when I'm given 3 equations, I'm going to try to see if there's something that we can easily take care of. And I can see that the first and the third equation both have a negative 2x and a positive 2x. So that's going to take care of itself easily. So let's use those first and third equations. So the first and the third. So we have negative 2x plus y plus 2z is equal to 2. And then our third equation is going to read as 2x plus y minus z is equal to 0. So the negative 2x and positive 2x cancels out. We have the y plus y gives us 2y, and the 2z minus z gives us a positive z equals to 2. Okay, so we took care of the x's. Now we're going to take care of the x's in equations 2 and 3. So equation 2, equation 3. Equation 2 reads as 4x minus 3y plus 3z is equal to negative 20. And then equation 3 reads as 2x plus y minus z is equal to 0. We're going to multiply the second equation by negative 2 to cancel out the x's. The reason why we're canceling out the x's is because when we compared equation 1 and 3, our new simplified equation is 2y plus z equals 2. There's no x in sight, And we're going to try to do the same thing where we have no x in sight for equations 2 and 3 combined. So rewriting this, we have 4x minus 3y plus 3z is equal to negative 20. And then for our second equation, we have negative 4x minus 2y plus 2z equals to 0. The 4x and the negative 4x cancel each other out, and we're left with negative 5y plus 5z equals to negative 20. Now that we have our two equations, 2y plus z equals 2, and negative 5y plus 5z is equal to negative 20, we're going to try to get rid of one of the variables. I'm going to get rid of the z's in this case. So to get rid of the z's, we're going to multiply the first equation by negative 5. That gives us a new equation of negative 10y minus 5z equals to negative 10. And our second equation has negative 5y plus 5z equals negative 20. As you can see, the 5z's, negative 5z and positive 5z cancel each other out, and we're left with negative 15y equals to negative 30. That means y must equal to positive 2. So once we have y equals to positive 2, we're going to substitute it into one of our equations. Let's substitute it into this red equation right here. The red equation we had was negative 5y plus 5z equals negative 20. So 2 times negative 5 plus 5z equals negative 20. And in this case, negative 5 times 2 is negative 10 plus 5z equals negative 20. If we add 10 on both sides, we're left with 5z is equal to negative 10, or in this case, z equals to negative 2. So we have z equals negative 2, we have y equals to 2, and now we're going to solve for x. So if I want to solve for x, I'm going to use the third equation from the original set. That looks like the easiest one. So we have 2x plus y minus z equals to 0. So I'm going to keep my 2x, I'm going to plug in my y, which is 2, and then I'm going to plug in my z minus z, which is negative 2, equals to 0. So 2x, this simplifies to being 2x, 2 plus 2 minus negative 2 is 2 plus 2 is 4, equals to 0. And then we subtract 4 on both sides, and we get 2x equals to negative 4, or x equals to negative 2. So I'm going to write it right down here. Our final solution, x equals to negative 2, y equals to 2, and z equals to negative 2.